Hello, I will be presenting our project called the Unit Transportation Fridge. This is phase D from capstone 2. My name is Madeleine Malavé. I will be working the thermal subsystem, and my partner Paola Contreras will be working the controls subsystem. Here I present you the agenda. First, we'll have the system validations, and there are some subsections for those. That will be the validation objective, continuing with the prototype design, then MOPs to validate, and the verification procedure. The next part will be the project plan to explain the future tasks for the final phase, F, and the systems budget. Here will be the system validation. The first part is the validation objective. Here is a diagram of the prototype design. The idea is that the unit transportation fridge has to maintain an adequate temperature within a range of 0 to 24 Celsius degree in order to transport biological units such as blood or vaccines. Continuing with the prototype design changes, in the left we have the drawing of the design submitted on phase C2, and on the right is the design of the phase D. The units are in millimeters, and the main changes will be the decrease in size, the change in the door placements, and many other details that will be explained continuously. Okay, so many minor changes were done on the design for improvement. First will be the door placement. At first it was on the front plane at one side of the refrigerator unit, and it was moved to the top plane of the refrigerator. Then we have the dimensional changes. The whole design is smaller. The volume is less than the previous design submitted on phase 2. You can go back to slide 5 to observe the difference. And the last one will be the components placement. They are still at the back plane of the design, but it was modified the type of support for those components. Previously, some were inserted into the design, and others had another a little slide to be supported. On the second design, there are some components are still embedded into the design, but a design was added to support a metal design. These changes does not affect the form, fit, or function intended for the whole system, for the whole assembly. And continually will be explained how the MOPs are summarized and explained and validated, and showed how they didn't change at all. Here are the MOPs to validate. The first one MOPs will be from the subsystem of controls, and the first three, as the low rise time, the low settling time, and the low maximum overshoot, did not have any amendment. They were verified at phase D. The simulation was done using MATLAB, and they all passed in C1. The last of the subsystem that works with the thermal subsystem will be the constant temperature. The idea is that if the controller is stable, and that was established in C1, verified also with MATLAB, and passed in that same phase, working with the thermal subsystem on the constant temperature and how it works with the ambient temperature, the outside temperature, between 20 to 28 Celsius degree. It was established in phase A and modified in phase C1. It was validated through a physical test and needs to be verified. At the end, continuing with the thermal, it will be that it needs to have changeable temperature depending on the material and that the device do not need ice. We have that the minimum temperature is 0 degrees Celsius, the maximum will be 24 degrees Celsius. They were both established at phase A and B, validated through physical tests. Continuing with the thermal subsystems, we have that the setback coefficient should be between 0.010 and 0.077 volts per cable. The performance should be above 60, figure of merit nearly 0, and the efficiency above 8%. Those were presented at phase C1, verified, and the physical tests and simulations were done by calculations and physical tests. They all were verified and passed in phase C1. Continuing with the MOPs, there is one last of the thermal, that will be the efficiency above 80%. That was established and verified in C1 and the physical test. There's one subsystem that will be assumed as the previous member decided to not continue working the project, and that will be the structural subsystem. The original MOPs were more about the volume, the measurements, the weight that it needs to door or handle. The materials need to be keep a temperature, waterproof, leak-proof, and insulated. The MOPs amendments were all mostly assumed, but for example, the weight, it had to be amendment as also the materials, and that it will be waterproof. It will establish some between the pre-phase A until phase A, and that was when they were established by the previous member. The procedure type will all verified. The physical test will done to prove, to verify them. The phases in which they were verified, they will be after the completion of phase D, as we need the physical prototype in order for it to be validated. Now I will leave my partner Paola to continue with the verification procedure. Thank you.
Verification procedure. As part of the verification procedure, it will state the procedure to follow to verify the MOPs. The first slide of verification procedure, we have the MOP 5, 12, 16. These MOP to validate are work with ambient temperature, must be insulated to maintain the temperature, and materials that keep the temperature. As a note, these MOPs can be tested together since we can see the efficiency of the materials also if the ambient temperature does not interfere with the refrigerator temperature. So with that we can also see if the refrigerator materials are insulated. The tools are thermometer, chronometer, and Microsoft Excel. The thermometer is for temperature keeping, chronometer is to measure the time, and Excel is to annotate the measurements. As part of the procedure, we have to turn on the unit transportation fridge prototype by turning on the switch on the back, wait for the refrigerator temperature to stabilize, and record the temperature for 2 hours in a 10-minute interval for the ambient temperature and the refrigerator. So we will have 2 thermometer readings. Also a note, the thermocouple placed inside the refrigerator should be placed at the center. We have an image with the placement of the refrigerator and the thermocouple, and graph the temperature reading, and we must verify if temperature is not out of range. The second slide is to verify the MOP number 6. The MOP to validate is maximum temperature of at least 24 Celsius and minimum temperature of at least 0 Celsius. We need a thermometer and a camera. As the same as the previous, turn on the unit transportation fridge, wait for the refrigerator temperature to stabilize, record the maximum and minimum temperature of the refrigerator, take pictures as evidence. And the thermocouple must be placed also in the center. And the third slide is the MOP 13. The error measurement should not be out of measurement range. We need a ruler and camera, and we need to measure the height, the width, and the length of the refrigerator. And the MOP 14, we have to weight the refrigerator. The tools are scale and camera. We have to verify the weight and take a picture of the weight as evidence. And the fourth slide is the MOP 15, which it needs to have a handle. So on that one, a picture will be needed as evidence. And MOP 17, that the refrigerator is waterproof and leak-proof. We have to close the refrigerator if open and verify if the refrigerator closes completely and there are no gaps. We have to take picture of evidence of the build of the refrigerator. Now we have the project planning. So as part of the planning, we have the Gantt chart with the following activities, which are the validation exercises. The first one is to show the evidence of the prototype construction and MOP compliance using validation prototype. The second activity under system validation is to summarize the final verification and validation result for all systems MOPs, then the overall project conclusion and overall project recommendation. Then is the submission of the last part. Also, we have an updated system budget, which is shown on the next slide.